to do is to kick off today by trying to give a broad introduction to the topic of hazards and risk, and set up some of the narratives, some of the headline messages that we're going to hear throughout the day. And so one of the things that is really timely is that this is a really interesting moment to get into an understanding of disasters and of risk, because the world's getting ever more complicated, and it seems like the disasters are getting ever more complicated as well. This is the 2011 Tohoku earthquake, which produced an earthquake, a tsunami, knocked out a nuclear power plant, produced fire, and had a cascading economic effect across the globe. So this notion of pigeonholing particular hazards in particular places is harder and harder to continue with. And with that in mind, I just thought I'd draw attention. The announcement's gone out today actually about this. This is the UK government has started a big urban disaster risk hub, which is a £20 million consortium that's led by Edinburgh, but it's got Bristol involved, UEA, it's got Plymouth, a whole bunch of places that is involved in trying to look at disaster risk as a holistic, systemic problem. So it's one where it's not just the natural sciences, the physical sciences, working with social scientists, and working with development, and working with policymakers, and working with communication professionals to try and address one of the big grand challenges that we have for the coming decades. And one of the things that you'll come up in my talk, and there'll be other talks, is the way that geologists are now starting to work with engineers and with psychologists. You'll hear from Paul later on. He works with social scientists and historians. That to address the fundamental issues around hazards and risk, we need to be very interdisciplinary. Now, earth science, geography has always been very broad and interdisciplinary, and that's one of the reasons why we're at the kind of centre of it. So anyway, as always, I'd like to start with this quote. In a time of extraordinary human effort to live harmoniously in the natural world, the global death toll from extreme events of nature is increasing. Loss of property from natural hazards is rising in most regions of the earth, and loss of life is continuing or increasing amongst many of the poor nations of the world. I don't know a hazard scientist or a disaster practitioner who wouldn't agree that that perfectly describes the situation that we have at the moment. However, that is the opening line in the first hazard textbook that was published in 1978. That's 40 years ago. And frankly, it's disgraceful that that quote is still up today. What it tells us is that for the last few decades, we've really not done very much in terms of inroad into addressing one of the key issues that we have on the planet. And it's really one of those issues, that issue of why we haven't grasped the nettle, the difficult challenges of disaster risk that I want to pursue in this talk. So here's a plot of the number of disasters, geophysical, so solid earth, so tsunamis, earthquakes, volcanoes, in grey, and then hydromet, as we say, so atmospheric, so storms, flooding, etc., in blue. Across really the last few decades, the second half of the 20th century, along with economic damage. And you'll see that when that hazard textbook was written, right about here, 1978, was a time when actually we saw an increase in the number of disasters. And that's partly because attention was starting to be focused on it. In fact, there was a whole decade. The 1990s was the international decade of natural disaster reduction. But if you look at this graph, you'll see that actually the 1990s saw another big step up as more and more attention was played on disasters, but it doesn't seem to have reduced the number of disasters or their cost. This is demonstrated here the economic cost, and many of these peaks are individual events. This, for example, is Katrina. There's probably 1995, that's Kobe earthquake, and this one here is the 2011 Tohoku earthquake and tsunami that I just mentioned. So disasters are becoming more costly. Funnily enough, deaths actually are dropping as we generally build better. But we are saving up some big storms in terms of the increased number of population that's going into urban areas, going into coastal areas, means that we should expect some big events if they have a direct hit on a big city we should expect death tolls to rise. But in terms of the number of people affected, in terms of the financial losses, the costs of disasters are rising increasingly. So clearly, despite the point the hazards coming in here and an increasing attention to them, we don't seem to be doing very well at reducing them. And that's what it's all about, disaster risk reduction. So what is the problem? Well, one of the things it's not is it not that we don't know where the hazards are. It's not because we're incredibly clever as our scientists, it's because nature puts hazards more or less in the same place again and again and again. Our main template for this is demonstrated up here. This is a broad plate tectonic template framework for the planet. You can see the yellow lines. The vast majority, 95% of earthquake energy release occurs along those yellow lines. That's where most of the tsunamis occur. Most of the volcanoes also occur along those lines. You'll also see it shows the uplifted area, the mountainous areas that we'll see later on are part and parcel of plate tectonics. That tends to be where the landslides are. That tends to be where the floods get generated. And so, because, in this case, tsunamis and earthquakes and volcanoes, but you could make the same arguments for tornadoes, you could make the same arguments for the hydromet hazards. Because they're occurring in the same place, you'd think that would make it easy for us. It's telling us this is where the danger is, this is where the threat is. And so even with that information, that most hazards are not a surprise, and even with that information, we struggle to contain and limit the damage and costs of disasters. Why is that? Well, one of the points is that disasters are human incidents, and they bring people into it. So that one of the things that came through, particularly in the 80s and 90s, was a notion of trying to beat the hazards, to build science and engineering, to understand the processes, and thereby defeat through these kind of technology. And yet actually what you find is that often that doesn't work. So this is a little hamlet, La Conchita in California, where you'd see there's a back scar here of a landslide, or this is a landslide, but in 2005, January the 10th, there was a lot of rain on this slope, and that landslide got reacted, and you can see there's a little defense zone here that's put in as a result of this hazard. But actually a large lot of rain fell on that slope, activated it as a mudslide, and the mudslide came down here, destroyed 30 buildings and killed 10 people. And I went there in December, so maybe 8 months afterwards, and Jeannie here, she lives in this house, and she took me up this street. Now the mud had reached up to the first floor of Jeannie's house. The emergency responders used that window there to get onto the landslides to take the body of her best friend Charlie out across the road. And I say that very deliberately, because that's 10 people's not many, but that was the first time I learned the names and the stories of the people who actually died in this event. Anyway, Jeannie walked me up this street. Now every study that's been done on this says the next time we get a lot of rain on that hill slope, we're going to reactivate that mudslide. So all of these houses are in danger. And yet Jeannie said to me, well, I said, well look, no one's going to live here. And this house was for sale. Oops. And I said, well that's ridiculous. No one's going to buy a house because everyone says this is going to happen again. And she said, oh, you know what? The price of that house has gone up since the landslide. It's been sold and the price went up. People want to live there. And Jeannie is intelligent. She's read all the scientific reports. She's affluent enough at least to move out. She doesn't want to. That place has a hold on her and many of her neighbours that they're not leaving. So when I started studying hazards, I thought it was, we identified where the hazard was, we told people, and they kind of moved out of the way. But what we're finding again and again is that we know where they are and people are moving in to those danger areas. People like Jeannie who can kind of move out. And psychologists refer to this as place attachment. The reason why people don't seem to behave in the way that you expect them to, rationally. But actually it's pretty rational. Jeannie says to us, where did I move to? This area has got earthquakes, it's got wildfires, it's got floods, it's got landslides. You know, all of California is a hazard scape. And so what we see, this is a plot really showing the areas of the US where there's massive population change. So the areas in orange are people moving into it, and the areas in black or dark grey areas that are losing population. And what we see is if we accept the East Coast areas, we see that there's huge inputs into Florida and into Houston and indeed across the whole Gulf Coast. That is an area that has got chronic threat from hurricanes. You know that, they know that, and yet people are actively moving into those regions preferentially. These are people who are retiring, they've got money, they could go anywhere, and they're choosing to go to those places. The other ones are the west coast of the USA, Los Angeles, San Francisco, Seattle, where there's a really considerable earthquake risk. So the net effect there is that most people in the US are moving to places which have either got chronic hurricane threat or chronic earthquake threat. That doesn't seem to make sense, and yet these are the preferred places. And so this quote really applies to the US, but it equally applies to almost anywhere. It's becoming more vulnerable to natural disasters because of the societal trends, rather than any trends in nature. And really, that boils down to this: more people, more assets are getting put in harm's way. So we spend a lot of time identifying hazardous places, and then people move into them, and assets move into them, and that's why the economic costs and the human costs go up. I went out to Thailand. This is from Khao Lak in Thailand, a few months after the 2004 Indian Ocean tsunami, and this is an event that was a kind of game changer in the way that we see disasters. This event, located here, is Sweden's highest death toll in a natural disaster. That tells us something about the way the world is working now. Sweden's highest death toll in a natural disaster occurs halfway around the other side of the world. If you went there 100 years ago to this region, this is the Andaman Islands up on the left that were devastated, you would see a local culture with stories, presumably telling stories about how the sea was dangerous, would come in. You had local architecture building buildings on stilts with loose material that wasn't very dangerous. Skip forward 100 years, that is a famous shot of the German mother going out to get her family as the first waves come in. They all survive, but that family has lived in a completely different hazardscape, and over the course of a few hours has managed to get on a plane and come to the other side of the world. And it's not just them. The people who are in the hotels and working have come from inland Thailand, they've come from Burma, they've come from very different places, and there's no long-term social memory of these recurrent disasters. This is the modern kind of landscape that the hazard meets. So when the tsunami comes in, this is what it means. This is the modern world that sits along the coast. The locals live a mile inland. The main holiday complexes are right at the beach. So I spoke to one of the Kiwi guy who was a lifeguard that got a lot of people off the beach because he didn't know it was a tsunami. He just saw the wave go out. He saw the tide recede, and he knew that as a surfer, the bigger the amount of recession, the bigger the wave covered. So he got a lot of people off, and he said, you know, the thing is, you think of a tsunami as this wall of water coming at you. But all the way along the front in Thailand, these beach resorts are little shacks and cafes selling soft drinks, cool drinks, and ice creams to the tourists. He said the way you got to think of a tsunami is a wall of concrete and fridges coming at you. And that is a fundamental difference that was not there 100 years ago. So the physical process has stayed the same, virtually no difference. What it meets when it gets to the shoreline, in terms of our vulnerability, has completely changed. And you end up with this. This is part of that hotel complex, luxury hotel. It's actually the third apartment in. There was one there, and there's one there. And that's going to get rebuilt, probably is already rebuilt, and we're going to go there. Because we actually want, not to have this apartment, we actually want the one right by the beach to open the door and see the sea. So we, in this instance, are driving the change in that hazardscape as a result of our behaviour as well. Another example from Indonesia, a really nasty volcano, Mount Merapi, erupts usually every decade, but when it does, it unleashes these pyroclastic flows that come down and usually kill hundreds of people. And as a result of that, it's pretty well monitored. There's an observatory that watches the slopes. Right on the top, you see they're measuring gas, and Paul will talk a little bit more about this in terms of Monserrat. But as a result of the early warning here, they can give hours to possibly days of warning to authorities. And that means they can do a mandatory evacuation of the people that live. And as millions of people live just at the foot of this volcano. And Rudy here's a volcanologist, and Rudy says to me as we're walking down the slope, he says, you know, it's all very fine. He says, but we do this mandatory evacuation, and none of the villagers in the upper levels of the volcano evacuate. I said, what? What's going on there? He said, I don't know. It's something to do with the culture. They believe their ancestors have gone into the volcano and they'll talk to them and tell them what is. Oh my God, like, as we'll see later on, volcano science is really well evolved in terms of prediction and forecasting. And yet it seemed to be undermined by this. So and it was pretty clear that it ain't working. So Mar Barajan up there is a spiritual gatekeeper of the volcano. He's designed to commune with the local communities. But in 1996, in this village of Turgo, which is near the summit areas on the upper flanks, there was a volcanic crisis on, a mandatory evacuation in place, and the villagers not only didn't evacuate, they held a wedding on the Saturday night. And 38 people died in that community hall when a pyroclastic flow came through. And the excuse was that actually this was because they had held the wedding in an inauspicious day. So I had a PhD student, Kate, working on this, and what came out of this really was, yeah, there was this cultural, spiritual connection. But actually, you know, the real reason why they didn't evacuate is that up there, their livelihood is cutting down grass, feeding it to their cow, collecting the milk, and selling the milk. So they could evacuate, but who was going to evacuate their cow? And actually, they were making a rational, in my view, decision that they were more likely, their family was more likely to come to harm, in probability terms, of something happening to their one cow, or someone stealing their land or something when they evacuated, than the risk of sitting waiting for a pyroclastic flow. And I think they're probably right on this. So this notion of why people behave the way they do in hazard disasters actually makes rational sense when you understand the world that they occupy. You have to go in and listen and understand the hazards in their terms, not from just a purely scientific terms. Understanding the social dimensions and the cultural dimensions of hazards. So one of the things that actually comes out of this is that the whole notion of what is a natural hazard actually becomes a little bit blurred because these are processes that emerge out of the fundamental physical processes of nature. But what actually turns them into the kind of events that we are hearing about is something totally different. So usually some part of the human system. And in some places, that blurring is even more confused. So this is Indonesia, this is Eastern Java, and this is the Lusi mud volcano. And this is a big argument in terms of geoscience about what triggered this. So basically, in 2008, there was drilling going on for natural gas in eastern Indonesia. This is an area of active volcanoes, and it's well known that actually underneath the ground, as a result of all the activity, there's relatively young mud sediments that are under a lot of pressure, the pressure of the overlying rocks. And as a result of that, when they explore for natural gas, they have to be very careful about protecting the drill line to make sure that the mud doesn't come out. Except that in this instance, when they were drilling, it looks like they didn't drill all the way down, they didn't protect the hole all the way down, and as a result, mud came out. But there's another argument that says, no, that's actually because there was an earthquake that actually happened and triggered this. But either way, the mud came up the drill hole and it's flooded us. 35,000 people have lost their homes and millions and millions of dollars of damage here as a result of a human-induced process that ended up being creating huge damage. So is that natural? There's elements to it, but it's not entirely. This one is even worse. This is so-called promised land. This is in the Philippines. And that is this is the main rubbish dump, garbage dump in Quezon City. So there's a whole squatter community that live around this and indeed work the garbage. That's their kind of job. July 2000, there's a landslide of this that sweeps in and kills 218 people, displaces hundreds and hundreds of homes, so there's thousands of people displaced. That is a landslide that operates on the same processes as any other landslide, but it's made of human garbage inside our cities. So disasters don't live out their nature, they're coming into the cities and the cities are getting bigger and bigger. So in terms of the problem we have, this is the one that I think is most acute. We understand the physical process pretty well. We can engineer pretty well for the processes to happen, and yet disasters occur again and again and again. This is a primary school that was destroyed in the 2008 Sichuan earthquake. You'll notice that the office blocks on either side are undamaged. In the early part of the 21st century, we can design office blocks not to withstand earthquakes, but not schools and hospitals, which happens again and again and again. So the reason this happens is because of a whole bunch of stuff around corruption and governance and issues that seem quite far away from the physical processes of the earth. But if we're trying to communicate this about how disasters work, it's all connected. It's all this interdisciplinary way. So this is the kind of thought I want you to take away. Society, rather than nature, decides who's most likely to be exposed to dangerous geophysical agents. The earthquake didn't decide that. The people who built that, municipal buildings, very low cost, very fast, they decided that. So where are we? Well, what's been interesting, in 2015, a new framework came out. The Sendai Framework for Disaster Risk Reduction says we've got to get away from this technocratic science engineering approach dominating it towards a more broader, more people-centered approach where the communities themselves are actually involved in the research process that is dictating to them. And that's referred to as the Sendai approach, and that's really my final kind of thought really, that the hazards, yes, they're made in nature. The disasters, we make them right here in society. Thank you very much.